So this video is for linear regression in R. So first of all, we have to go back to very basic of linear regression. Let's going back with the very basic linear regression, which is simple linear regression. So for this, we want few things. What we need? First of all, we need a data, a bivariate data. So that is, we have a data called X and Y. So for n individual, suppose we have data of two variables denoted by xi, yi. Now, our purpose is to predict y based on the values of x. That is, we want to know the value of y for some values of x. For this, we model y with a linear function of x, that is y equals to a plus bx. And this equation is called the simple linear equation or simple linear regression, where the a and b are the model parameter which we have to estimate. For estimating A and B, we use the least square method. For this, we assume that here is some error component E, and by minimizing the sum of square errors, we obtain the estimate of A and B as A hat and B hat by the least square technique by solving the normal equations. Okay. In R, we don't have to solve this normal equation. Rather, very easily we obtain this estimate of A and B. The inherent mechanics all do the all calculation and give us the only result. Okay. For this, the first of all, we need some data. So we will begin with the data we used previous video. That is the age BP weight. So we are taking these three variables, Control C, and here we are taking to my new document, which is so I have three variables, age, BP, and weight. Okay, let's run this variable or store this variable. Now, my first purpose, I am taking with any two variable. That is, I am taking age and BP for same. Okay, so I want to predict BP based on it. That is, my BP becomes Y variable and age becomes X variable. So I want a regression model y on x, that is y equals to a plus bx. I am removing x for now. Okay, so my x variable is age variable and my y variable is bp variable. I want a regression line age y on x, which is bp on age. That is, I want y equals to bp equals to a plus b into age. In our, here is a function called lm to fit a regression model. So let's give it a name M1, which is LM, BP, which is Y tilde, which is various Y various age, which is Y depending upon age. And this means if we run this, if we see what M1 gives us, M1 gives us the estimates of the parameters. The first one is intercept, that is the A component here. And the second one is age, that is the B component, which is the coefficient corresponding to the variable age. Okay. Yes. So by a single code, we have these estimates. Basically, R use the least square technique to find this estimate, and which is done within R. It doesn't shows the this doesn't shows us the intermediate shapes. It's okay. Now, my purpose is when we have a regression line, I want to plot it, right? Like this. If this is my scatter plot, okay. If this is my scatter plot, Now I want a line from this data which fits the data as good as possible. So I want this kind of picture in this data set. So for this, we first need the scatter. So for scatter plot, we want the plot of age and BP. Okay, and we want the PCH to be 20. Let's plot this. Yes, it is the plot. Here is the age, here is BP, here is X, here is Y. So this is the scatter plot. And now I want to fit the regression line, which is AB line of model M, which is model M. Okay. Now this is the black line, but I want this to be red. So let's change the color to be red for better understanding. Yes, it is the red line. So this is my regression line BP on H. Okay, that is BP equals to 102.17 plus 0.78 H, right? So this is the very basic, which is simple linear regression, which is the first regression we have learned in the first semester. Now, what we will do is something more, which is polynomial regression. That is, y not only depend upon x, but also some power of x. I will go with very simple of that, which is, let's clear the board first. Clear all my drawings. Yes, it is. So by polynomial regression, y, which is my response variable, that depends on some power of x, which is a plus bx plus cx square. Now, I have to solve three normal equations by the to estimate a, b, and c. And by least square technique, solving the three normal equation, I have the estimate of a, b, and c. Okay, sorry. In R, I can do it very easily. The same function will be used. So basically, here our y variable is BP, age variable is age, x is age. Now another variable we are naming is as z, which is age square. Let's run this. Yes, z has run. Now I will do a linear model, which is LM, which is given by name M2, LM of y tilde y, sorry, I don't have y, which is BP tilde age plus z. Okay. Now BP tilde h plus z is this. Let's see what M2 gives. M2 gives the coefficient of the three component, which is the A, which is the intercept, B, which is the coefficient corresponding to variable h, Z, which is the coefficient corresponding to the variable x square. So this is my regression model, which is BP equals to minus 677.19 plus 36 into h minus 0.4 into h square. Okay. If we know, if we want this plot, okay. So now I have this variable. Now I want this plot. So to know, get this plot, I don't use the function called AB line because this is not a linear, right? Here is three component. Okay. So it is not a linear, it is a quadratic. So to plot this, I want to plot the predicted values. Okay. So now I will see how to get the predicted values. If we going back to the previous example with simple linear regression, we have y equals to a hat plus b hat x, a hat plus b hat x. Now putting the x values, we will get the estimate of y, which is y hat. That is the predicted value of y. So similarly, here also putting the a hat, b hat, and c hat for each of the x's, we will get the predicted value of y. So let's see how to get this predicted value. To get the predicted value, we use the function predict or pred. predict, first of all, we will use M1. So this is the predicted value for the first model. And if we use predict M2, this will be the predicted value for the second model. And that is the polynomial regression. This is for the simple regression. This is for the polynomial regression. So getting this predicted value from the second model, I can fit the predicted value for the age and get the plot of the regression. Okay. So this is the very basic of the polynomial regression. Now, let's going to a deep, which is multiple linear regression. That is, okay, let's see what a multiple linear regression is. So I have a variable y, which is my response variable. And now this y, depending on many more covariates, that is many more independent variable, that is this is dependent of some constant mu plus, okay, sorry, suppose y is my response variable that is dependent upon many more variable, that is x1, x2, dot, let's see xp. That is the y is response variable is depending upon p another variables. That is here is p independent variable. Okay. So now then my model will be y equals to mu plus beta 1 x1, that is the coefficient corresponding to the x1 is beta 1 plus beta 2 x2 and so on. Preceding this way, we have the last variable as beta p x2. So using the least square, we also get the estimate of mu by mu hat, beta 1 by beta 1 hat, beta 2 by beta 2 hat, and so on and so forth. And in R, we can get it very easily. So let's see how to get this in R. So for our data, let's consider that, which is multiple linear regression. So let's give it a name by M3 and LM. That is my, going back to the BP, is depending upon two variables, let's say age and weight. So my Y is response variable, which is BP, that depending upon age plus weight, two variable. That is here P is 2, X1 is my age, X2 is my weight. Let's see what is it. If we fit this and run the M1 or M3 here, sorry, M3. Here is three coefficient, which is first intercept, which is mu, this is beta 1, and this is beta 2. So my y hat will be obtained by mu hat plus beta 1 hat plus beta 1 hat x1 plus beta 2 hat x2. That is, BP will be predicted by minus 58.460 plus 0.1422 into h plus 2.69 into 8. That is, the impact of the weight variable is more to BP. Okay. Now, let's see how to predict the values from model. So now predict, then the model name. Now this will give me the model name, or rather the predicted value of y, right? Okay. And now we can feed these predicted values of y for each of the different variable on the scatter plot and get the fit. Basically, since it is depending upon two variables, so the scatter plot will be not so easy. It will be a 3D scatter plot and the line will be not so much good. So I am not plotting this, but if we want to plot by with a pair, that is BP with age or BP with weight, then we can do it very easily by plotting BP and age and plotting age and this predicted value, or plotting BP and plotting weight and this predicted value. This will give us the fit, more or less. This is all about the regression. This is the very basic class. Uh, the regression or the LM function is much more than this. Much more means very, very more than this. So it's a very basic introduction for this time being. Okay. Thank you.